So for the next presentation, we have a slight change in the program. The presenter that was listed is not here. So the presentation we'll have is by Edda Kalbus on strategic water storage and recovery with desalinated seawater in Liwa, United Arab Emirates. Thank you, Edda.
Yeah, thank you very much for upgrading me from a flash presentation to a full presentation. I really feel very honored to be able to talk about our project here today. Not sure where the slides are. There we go. So I work for Transco. Transco is a government organization of the United Arab Emirates, of the Emirate of Abu Dhabi to be precise. And Transco is responsible for transmission of water and electricity in the Emirate of Abu Dhabi, and they are also tasked with the management of a strategic water storage and recovery project that I will talk about today. Now the project has been in development for almost 20 years now. I just joined the party about a year ago, so not too much contribution from my side, which means that all the credits should really go to my colleagues, and particularly George Kozierowski, who was with the project pretty much from day one. So I will be talking about a bit of the background of the project. Why do we need strategic storage? Why was it built in the first place? Why is it located in the middle of the desert, far away from a major city? And how does it sit within the water supply system of Abu Dhabi? Just a quick refresher of where Abu Dhabi is located. So it is located on the Arabian Peninsula. You can see it there to the left of the map. There's Saudi Arabia, there's the Arabian Gulf, also known as Persian Gulf, and the United Arab Emirates is at the southern shore of the Arabian Gulf. Now the Emirates is a federation of 7 emirates, Abu Dhabi being the largest one in terms of area. And Abu Dhabi is the capital of the Emirate of Abu Dhabi and also the capital of the United Arab Emirates, just for those who didn't know. I also showed on that map the location of the actual project, and you can see that it is quite a distance away from Abu Dhabi city, and I'll talk more about that later on. Now, Abu Dhabi is a pretty hot and dry place. We don't have any surface water resources at all to speak of. So our water resources are groundwater, recycled water, desalinated seawater. Now groundwater is mostly brackish to saline, and it is used for agriculture. And a bit of recycled water is used for landscaping, but as you can see, all, and I repeat that, all of the municipal water supply is from desalinated seawater. So all domestic, municipal, commercial, industrial water is exclusively from desalinated seawater. Now we have 5 major desalination plants. And now you can imagine what happens if something happens to those desalination plants when all of the municipal water supply depends on them. There are a couple of threats to desalination plant operations. Contamination, for example. We frequently or regularly have red tides in the area, so that's a bloom of algae, and that occur in the Arabian Gulf, but also in the Gulf of Oman, and there have been occasions when the desalination plants had to be shut down temporarily when there was a red tide. Oil spills are another risk, given that there's quite a bit of oil tanker traffic in the region, or other kind of pollution. Then, of course, technical failures can always happen. And then there is the risk of intentional disturbance, and considering the geopolitical situation in the region, there may be a risk of, unfriendly acts from certain groups. So all these can be a threat to desalination plants. So what happens if the desalination plants fail? There is a certain amount of storage in the transmission system, but when you look at the numbers, it's really not that much. So each desalination plant does have storage tank equivalent to 24 hours of its production. Then we have a lot of pumping stations in the transmission system. Each of those has also storage a capacity of about 24 hours of its pumping capacity. And then we have end-user storage, meaning that every household, or every house, every building pretty much has a little storage tank with water for a few days. So in case there is a major failure of the desalination plants, when you look at those numbers, it's really only a few days of storage that we have available. Another thing to consider is that the water production process is actually a cogeneration process. So the same plants produce power and potable water. Really? Yeah, and so to make it short, we do have in certain times, there is a bit of a difference in electricity and water demand over the years, and at some times we do have actually excess of water. So the idea was, why not use that excess water and store it for emergency situations in case something happens to the desalination plants. Okay, now options for storage. There is surface water storage in theory, but not really in the UAE. It's a dry and hot country, high evaporation rates, high infiltration rates, not really an option. There could be ground storage tanks. Here I put an example from Saudi Arabia, but this is very expensive. So also for large volumes that we require, not really a good option. And so aquifer storage is really the only feasible option. And there are certain areas in the Emirate of Abu Dhabi that are really, really perfect conditions for aquifer storage. And one of those is the Liwa area in the Emirate of Abu Dhabi. And so I'm not going through all of that. Here's just a quick time frame of the whole project, just to show you what kind of time frames are involved in developing such a project. And 2001, there was a feasibility study, 3 to 4, a pilot project. 2009, the construction of the actual recharge facility started. December 14, recharge operation started, and then there was a continuous operation over almost 3 years until the November 17, when the recharge is complete and the system is now fully recharged and is currently waiting, it's on standby, waiting to be used in case there is an emergency. So the project is located around Liwa. The supply point would be Abu Dhabi city, and there's about 250 kilometers pipeline in between, which would say, oh, wow, that's quite far away from where you want to be. But this is really due to the location of the study area. Here, just a quick map of the groundwater levels, and you can see that the study area actually sits on a little mound, a groundwater mound. And more importantly, on the next slide, this mound is actually a freshwater mound. So the rest of the country basically has brackish and saline water, but there is a little mound of fresh water. And so this is why the location was chosen there. Yeah, the cross-section just highlights the same thing. You see the study area is in the middle of the figure, more or less, and there is just that freshwater aquifer, or mound in the aquifer. Okay, this is pretty much how it looks like, and I'm almost at the end of the presentation. This is more or less like the study area. There was the pilot project, and then about 20 kilometers away, the final project consists of 3, what we call schemes. They are essentially 3 individual research facilities that can be operated individually or in conjunction. This is a close-up. You can actually easily find it on Google Earth when you know where to look. These are the 3 schemes, and this is a close-up on one of the schemes. You see in the central recharge basin in the center, surrounded by recovery wells. So there is 1 infiltration basin in each scheme. We have 105 recovery wells. We have 10 sets of 3 clustered monitoring wells at different depths. And each scheme has its own storage tank and pumping station. And each of those wells has monitoring devices in it as well. And I thought it would be interesting. The infiltration basin is actually a constructed basin made of gravel and buried pipes to avoid evaporation, so there's never any standing water in the infiltration basin. And just a nice figure how it looks like. In terms of numbers, so we have a recharge rate of around 30,000 cubic meters per day. When we recharge over 27 months, we have a total volume of 26 million cubic meters. And the recharge is designed in a way that we can recover 180,000 cubic meters per day. And over 3 months, that would sum up to 60 million cubic meters. So we can supply a population of 1 million with 180 liters per person per day over a period of 90 days. And so you can see from that this actually really significantly increased the water security for the Emirate of Abu Dhabi, being able to supply that amount of water. And in an emergency situation, you could even, you could think, okay, you don't need 180 liters per person per day. Less is also enough for survival. And so if we talk about, a survival situation, you could supply for a much, much longer period. Right, now, future work. Considering that it's a cogeneration process, power and water, which means if the plants fail, we not only have no water, we also have no power. So how do we run the pumping stations and such? So there are plans now, future plans to, first of all, provide the system with its own power supply and also develop a grid-independent transmission, so pretty much bypassing all the pumping stations on the way and just supply Abu Dhabi by gravity drainage over all the 250 kilometers, which is possible, but it needs a bit more work to study that. Also looking at using it in a more dynamic way. As I said, it's currently just sitting there waiting for an emergency to happen, which hopefully never will happen, but there's not really much use of it. So using it in a more dynamic way, or in a seasonal way, probably using excess water when available, using power when it's cheap, to come to an optimization for that. And also currently there is not really groundwater protection zones around the facility, so that's also something to think about, considering that's a shallow unconfined aquifer. All right, that was it from my side. I just wanted to acknowledge all the major companies and institutions that are involved in the project, and I thank you very much for your attention.
Maybe we take the question at the end.
Yeah, good idea. Thank you, Edda. What we might do is take questions on the last presentations at the end. So hold on to your question, please, and we'll take them at the end.
Okay, sure.
Edda's a very adaptable person. We upgraded you and then told you had to reduce your time. The reason for, and we apologize for that, but you did very well. The reason for that was we were told that one paper wasn't going to be delivered, but it is going to be delivered.
All right,
so,
I see. Okay.
So we have an extra paper, so we'll beg your indulgence and go over time just by 10 minutes or so.